Hello, my expert chemists. Today we are going to talk about gas laws and stoichiometry. So we know that stoichiometry is calculations in chemical reactions, and we can link between one substance and another using the Molar Ratio. We have been talking about gas laws. The most important gas law is the ideal gas law, PV equals nRT. And so the link between the two is moles. So one of two things. Either we're going to use PV equals nRT to find moles of a gas, and then use stoich to find moles of a different substance, and then something about it like grams or atoms or something like that. Or we are going to use stoich to find moles of a gas, and then we are going to plug it into PV equals nRT to find either the pressure, the volume, or the temperature. So let's try the first example here. It says, what mass of NaCl could be produced from excess sodium and 10 liters of chlorine gas at 23 Celsius and 1.02 atm? And so it's talking about a chemical reaction, so the first thing we want to do is write the balanced chemical equation. And so it's telling us NaCl is produced, so that means it comes after the arrow. And it's produced from excess sodium, so that's Na, and chlorine, which is Cl2. And then to balance it, we need a 2 here and a 2 here. Let's write down what we have and what we're asked for. We're asked for the grams of this. We are given excess sodium, so that means don't worry about it. It's the excess reactant, not the limiting reactant, so no need to worry about it. The chlorine we know is 10.0 liters. And then we're given a pressure and a temperature. Now, pressure and temperature are only relevant for gases. And so if you look at your chemical reaction here, sodium is going to be a solid. NaCl is an ionic substance, which is a solid also. And so the only gas that we have is really chlorine. And so I'm going to go ahead and write my temperature and pressure under chlorine, because that's where I would need them if I use them. So 23 Celsius, that would be 296 Kelvin. Remember, with gases we have to use Kelvin. And we have 1.02 atm. So I wrote down my equation, balanced it, and then wrote down what I have and what I'm looking for. So then you ask yourself, well, what am I trying to find? Well, I'm trying to find grams of NaCl. But I don't have any information about NaCl. The only substance I have information about is the chlorine. So that means I have to link chlorine with NaCl somehow. And the only way to link between different substances is through the molar ratio, which means moles. And so I need to find moles of chlorine first, then I go to moles of the sodium chloride, and then the grams. So with any stoich problem, no matter, if it's stoichiometry and gases, or stoichiometry and thermochem, or stoichiometry and anything, 3 steps, always. The first step is find the moles of the substance that you have information about. In this case, it's going to be the chlorine. Next, find the moles of the substance you're interested in this case, the NaCl. And then lastly, answer the question, which is the grams. So I'm going to repeat that again. Find the moles of the substance that you have information about, then find the moles of the substance you're interested in, and then answer the question. So let's first find the moles of the chlorine. Well, chlorine is a gas. I'm given the volume, I'm given the temperature, I'm given the pressure. So PV equals nRT, doo-da, doo-da. I always recommend when you're doing a chemical reaction like this where there's multiple substances, whenever you write PV equals nRT, write down what substance it's for. So my pressure is 1.02 atm. My volume is 10.0 liters. My N, that's what I'm looking for. My R, since I have atm for my pressure, is 0.0821 atm times liters per mole Kelvin. And my temperature is 296 Kelvin. So I'm going to solve for N. When you plug that in and you solve for N, you get that N is 0.42 moles. And this is going to be for chlorine. Now, the reason why I recommend you write Cl2 here, or whatever substance it is once you get to the moles, you know what substance it's for. Because what I see on the test a lot is people will do PV equals nRT and get moles, and they're going to think, oh, it's moles of NaCl, when it's not. It's the chlorine. So now we have moles of chlorine, so next we're going to find moles of NaCl, and to do that we're going to use our molar ratio. So moles of Cl2 on the bottom, moles of NaCl on top, and it's a 2-to-1 from our equation. Moles of chlorine cancel, now we're at moles of NaCl. And so finally we answer our question, which is how many grams. Now that we know moles of NaCl, we can find the grams. So we're going to put moles of NaCl on the bottom, grams of NaCl on top, 1 next to the moles. For the grams, you add up sodium, which is 23, and chlorine, which is 35.45, and it's 58.5. Moles of NaCl cancel, you get the grams, and you get 49.1 grams. And that's our answer. So in this case, we use PV equals nRT to find moles of the gas, and then we use stoich to find the moles of something else, and then the grams. Let's look at the next problem. Next problem says calcium carbonate, which is basically chalk, decomposes to form carbon dioxide and calcium oxide. What volume of carbon dioxide at 25 Celsius and 99.8 kPa is produced if 25.0 grams of calcium carbonate is decomposed? So long problem, lots of information. First thing you want to do is write your chemical equation and balance it. So calcium carbonate, that's ionic. Calcium is 2 plus, carbonate is CO3, 2 minus. So CaCO3 decomposes, so arrow, to form carbon dioxide, that's CO2, and calcium oxide. Calcium is 2 plus, oxide is 2 minus, so CaO. And it's already balanced. Let's write down what I have and what I'm looking for. So it's asking what volume of carbon dioxide, so question mark V for volume or L for liters, whichever you prefer. I have a temperature and a pressure, and I have 25 grams of calcium carbonate. So 25.0 grams here. For the pressure and the temperature, remember those affect only gases. And so if you look at your substances, calcium carbonate is ionic, it's a solid. CaO is also ionic, it's a solid. So my only gas, it's the CO2. So I'm going to go ahead and write my temperature and my pressure under this one. So 25 Celsius is 298 Kelvin. Remember, we have to use Kelvin in this chapter all the time. And then 99.8 kPa. So then, you ask yourself, what am I looking for? Well, I'm looking for the volume of the CO2. Great, well, it's a gas. I have its temperature, I have its pressure. So let's do PV equals nRT. And we're going to do that for the CO2. Well, I have the pressure, it's good. I have R, because it's a constant, I always know it. I have the temperature, great. I'm looking for the volume, but I don't have the moles. So that's a problem. I can't plug it into PV equals nRT yet. So I have to find the moles of the CO2 somehow to plug it in here. So no problem. My only other number I have is calcium carbonate, so maybe I can use that. So what I'm going to do is find the moles of the calcium carbonate. Then I'm going to go to moles of the CO2 using the molar ratio, and then I can plug it in here. So let's do that together. So we're going to start with this and find the moles of that calcium carbonate. So I have 25.0 grams of CaCO3. I can use my molar mass. 1 mole of calcium carbonate on top, grams of calcium carbonate on the bottom. We're going to add a calcium, which is 40.08, plus a carbon, which is 12, and then 3 oxygens, 16 each. That is 100.1 grams. And now I get moles of calcium carbonate. Next, I'm going to find moles of the substance I'm interested in, which is the CO2. So moles of calcium carbonate on the bottom, moles of CO2 on top, and it's a 1-to-1 ratio. And so I have 25 basically divided by 100, which is 0.25. And this is of CO2. Now that I have moles, I can plug it into PV equals nRT, so let's do that. So PV equals nRT, I'll just put it on the bottom here again, the CO2. So my pressure is 99.8 kPa. My volume is what I'm solving for. My N, I just found out to be 0.250 moles. My R, since I'm using kPa, is 8.31 kPa times liters per mole Kelvin. And my temperature is 298 Kelvin. Plug that into your calculator to find the volume. And we need 266. And it is 6.2 liters of CO2. So always find the moles of the substance you have information about, find the moles of the substance you're interested in, and then answer the question. Have a great, wonderful rest of your day. Bye, guys.